Hey guys, welcome back to session 6 of Introduction to Linux OS. Today we're going to be going over shells, pipes, fish, and Z shell. So in session 5 we covered file system organization, file types, file and directory naming rules and conventions, commands for navigating the file system, introduction to inodes, ownership, permission, and dates, manipulating files and links, determining disk usage, and other file system utilities. Today, we're going to be going over input, output, redirection, and pipes, command separation and grouping, background extension, file name expansion, shell variables, command substitution, quoting and escaping meta characters, Z shell features, fish shell features, command execution, startup files, and customizing the user environment. So let's go ahead and dive right in. Let's talk about input and output redirections. Most Unix system commands take input from your terminal and send the resulting output back to your terminal. A command normally reads its input from the standard input, which happens to be your terminal by default. Similarly, a command normally writes its output to standard output, which is again your terminal by default. Output direction is when the output from a command is normally intended for standard input and it can easily be diverted to a file instead. This capability is known as output direction. Okay, so let's take a look at this example down here. So if the notation greater sign file is appended to any command that normally writes its output to standard output, the output of that command will be written to the file instead of your terminal. So when we look at this example, we see who, which is a command, is redirected to this file users here. Okay. So standard input, in this case, is going to be this command input, or command who. Its output would normally come back to the terminal and show us the result of this command, but instead, this greater than sign is directing it to the file users, okay? So the output from who is getting redirected to users, okay? So let's go ahead and run that command real quick. Alright, so I'm going to write who, WHO, which is a command. Let me show you what this command normally does. So this just shows you what users are on the system. So I'm going to do who, I'm going to redirect that to a file called users, okay? In this case, the file users doesn't actually exist yet, but since I'm running this, it's going to go ahead and create that file for me. I'll hit enter, I'll do an ls, you'll see the file users now exists, and I'm just going to cat what's in that file, and you'll see in that file is the output. So the standard input was who, the output of who got redirected to the file users, and then we see that the standard output was placed in the file users. So then we see back in our PowerPoint it's saying that you notice no output appears at the terminal, and that's because it was redirected to the file users. If a command has its output redirected to a file and the file already contains some data, that data will be lost, okay guys? So that's important. Keep in mind when you redirect something to a file, if there's info already in that file, it's going to be deleted and replaced with what you're redirecting, okay? So let's look at the first example here. So we say echo line 1 into users, and then when we cat users, we'll see that it says line 1, okay? If anything else was in that file, it would actually be deleted, okay? Alternatively, you can use two greater than signs, and this is going to append the output into the existing file. So we'll actually add whatever data or whatever output you're doing, and it's going to add it to the end of the file. So we look at our second example here, echo line 2, greater than sign, users, and we cat users, and it's going to say line 1, line 2. Okay, so let me show you that real quick. So cat users, you see that's in there, okay? So I'm going to say echo line 1 into users. Oops. So actually I made a new file on accident. Users, there we go. I'm going to say cat users. And you notice it says line 1 now. So if I say echo line 2 and I append it to users, now I cat users, you'll see that it's actually added to the second line. Okay? So as the greater than character, which is this character here, is used for output redirection, the less than character is used to redirect the input of a command. Upon execution, you will receive the following output. You can count the number of lines in that file by redirecting the standard input of the word count command from the file user. So we see here you can actually use that symbol to redirect the other way. Okay, so we have the file users here that's going to be sent into the command word count. Okay, so let me show you that for you real quick. Let's clear our screen. So Control L. I'm going to do word count -L, and all this does is count the number of lines in a file. And it tells me there's 2 lines. So it sent the input from the file users and it redirected it into this command. Okay? A here document is used to redirect the input into an interactive shell script or program. The general form for a here document is command space less than space delimiter. Okay? Here the shell interprets the less than operator as an instruction to read input until it finds a line containing the specified delimiter. Okay? All the input lines up to the line containing the delimiter are then fed into the standard input of the command. The delimiter tells the shell that the here document has completed. Without it, the shell continues to read the input forever. The delimiter must be a single word that does not contain spaces or tabs. Okay? So it's looking for a specific delimiter, and once it sees that, it's going to stop reading it. Okay, and guys, just so you know, we're covering this at a very high level. Okay, so no need to try and understand this too much. It's going to be covered in much more depth in our next course, Intermediate. Okay, in this section we're going to discuss briefly about pipes and filters in Unix. You can connect 2 commands together so that the output from one program becomes the input of the next program. 2 or more commands connected in this way form a pipe. To make a pipe, put a vertical bar, which is this symbol here, and that's usually going to be above your enter key, on the command line between 2 commands. When a program takes its input from another program, it performs some operation on that input and writes the result to the standard output. It is referred to as a filter, and this is commonly used with the grep command here. Okay, so we see here the grep command searches a file or files for lines that have a certain pattern, and that's going to be grep space, the pattern you're looking for, or the text you're looking for, space, what file you want to use it on. Okay. The name grep comes from the ed, a Unix line editor command, grep, which means globally search for a regular expression and print all lines containing it. Okay. Again, pipes are going to be covered in much more detail in our next course, Intermediate Linux. The simplest use of grep is to look for a pattern consisting of a single word. It can be used in a pipe so that only those lines of the input files containing a given string are sent to the standard output. If you don't give grep a file name to read, it reads its standard input. That's the way all filter programs work. Okay? So in this example here, we have ls-l space pipe space grep space and then quotation marks AUG for August. So it's going to take the output from ls-l, it's going to send it into this command grep, and it's going to say search for all things that have the word August in it, AUG, and it's going to send you back what it finds. Okay. There are a couple different options you can use with grep, such as -v, which prints all lines that do not match the pattern, -m, which prints the matched line and its line number, as well as -l, which prints only the names of files with the matching lines. The sort command arranges lines of text alphabetically or numerically. The following example sorts the lines in the food file. So we do sort food, and it sorts it here. You can see the example here. It's going to sort it alphabetically. By default, it's going to actually sort it alphabetically. Okay. All right, let's go to our next slide here. More than 2 commands may be linked up into a pipe. Taking a previous pipe example using grep, so the example we just used, we can further sort files modified in August by the order of the size. So let's take a look at our example here. We have ls-l space pipe space grep space August space pipe space sort space +4n. Okay, so the output of ls-l is getting piped into the input of grep August, which is getting piped into the input of sort +4n. Okay, So sorting everything by August. You see that here. So this pipe sorts all files in your directory modified in August by the order of size, and then prints them on the terminal screen. The sort option +4n skips 4 fields. Fields are separated by blanks, and then sorts the lines in numeric order. Again, we're going to be covering pipes and filters much more in depth in our next course, Intermediate Linux. So no need to worry about it too much right now. Alright guys, let's talk about command separation and grouping. So Bash provides 2 ways to group a list of commands to be executed as a unit. Placing a list of commands between parentheses causes a subshell environment to be created. See command execution environment for a little bit more details on that. And each of the commands in the list to be executed in that subshell. And we'll see here some common commands to be used for that. So add user, user delete, add group, delete group. And let's talk about background execution. So in Linux terminology, and in Unix in general, a background process is a process that is started from a shell or terminal and then runs independently. When a background process has been launched from a terminal session, the same terminal will be immediately available to execute other commands. In contrast, a foreground process takes control of the terminal when launched, preventing any other command to run until it is finished. And guys, we saw this in our last session when I was running that sleep command. When I ran it in the background, when I did sleep 60 and then I did that ampersand sign, it was running it in the background and I could still use my terminal. However, when I ran it in the foreground, you saw that I wasn't able to use my terminal. So let's look at the example below. So when I run yes example 1 and I redirect, so you see that greater than sign, redirect the output of this into the input of this, it'll take control of the terminal. Okay? And the only way to get out of that would be to run a signal interrupt or a signal suspend with Control Z or C. So let's go ahead and check that out real quick. And clear my screen here. So I'll do yes, example 1, and I'll redirect that into /dev/null. You'll see I lose control of my terminal here. So the only way to get out of that is Control C or Control Z. Okay. Let's go ahead and talk about file name expansion. Another way to save time in your commands is to use special characters to abbreviate file names. You can specify many file names at once by using these characters. This feature of the shell is sometimes called globbing. Okay, so anytime you hear the word globbing from someone else, they could be referring to file name expansion. So ms-dos or MS-DOS, which is Microsoft or Windows, provides a few crude features of this type. You can use a question mark to mean any character and an asterisk to mean any string of characters. Okay, Unix provides similar wildcards too to this, but in a more robust and a rigorous way. So let's take a look at the example below. Let's say you have a directory containing the following CSource files. So ls, you have your first file here. Oops. Okay, second file here. Oops, too much. There we go, second file there. Third file, fourth file, fifth file. Okay. So to list the 3 files containing digits in their names, you could enter docstore.mik.ua/O'Reilly/Linux/run/chapter48.htm. Okay, so we could do an ls, and we could throw that question mark in the middle there, and you see it's going to list the ones with the numbers in their name. Okay, 1, 2, 3. So the shell looks for a single character to replace the question mark, thus it displays those 3 files, 1, 2, and 3, but not the last one, because that name contains too many characters, as you'll see here. Let's go and talk about shell variables here. So variables can be created either at the shell or in shell scripts. Any variable created with a shell script is lost when the script stops executing. A variable created at the prompt, however, will remain in existence until the shell is terminated. So here we see our prompt. Okay. And then we see my var equals 999. So when we echo my var, it's going to say that variable equals 999. Okay. So variables are designated by that $sign. Okay, let's go ahead and take a look at that real quick. So we're going to say my var equals, let's make it a different number, 789. Okay, we're going to echo the my var variable, so we're going to say echo space $sign, and we have to make it spelled exactly right because remember Linux is case sensitive. It's going to say that equals 789. Okay. There's also a couple other variables by default in Linux, such as user. So we'll say echo $user, all capital. It's going to say the user's Kevin. Same with home. So we're going to say echo $home. What is that variable? And it's going to tell you your home directory. Okay. And you can see that here in the PowerPoint. You know, it says variable user. So echo RAM and then the variable user. And it's going to say RAM Datasoft. Datasoft's the user. So there's some more examples of shell variables. We can say echo RAM, and you'll see here user is not spelled correctly. It's all lowercase, which is incorrect. So it's only going to echo RAM because that's not the correct spelling of the variable user. We also see here echo this is the and then shell variable Datasoft. So it's going to give you the variable for the shell environment you're using. So this is the /bin/bash Datasoft. We see another one here. We can use multiple variables in one line. So echo, this is the shell variable on computer hostname variable. So this is the /bin/bash on computer Datasoft. So we have our shell variable here, we have our host variable here. Another example, echo the user ID of, and then we see user is spelled incorrectly again, it's all lowercase, is, and then the user ID variable. So we're only going to get the user ID variable here. The user ID of, and then blank because it's in the correct spelling, is, and then user ID variable. Okay. And then another one, echo my home dir or home directory is, and then home directory variable. So it's going to output my home directory is /home/Datasoft. Alright, moving along. Next we have command substitution. So command substitution is the mechanism by which the shell performs a given set of commands and then substitutes their output in place of the commands. So here's an example. The printing value of the variable is submitted by its value, and at the same time the /n character is substituted by a new line. Okay. So whenever you see this is actually a script. It's called a hash pling. Okay, this just designates the script and the shell environment you're going to use, but don't worry too much about that. So we see we're setting the variable a equal to 10. We're going to echo -e, okay, and this just means interpret this slash here. So we're going to echo -e /value of a is, and then the variable a, and the output of that is value of a is 10. Okay. Some more on command substitution here. Command substitution is generally used to assign the output of a command to a variable, and this is very useful for when we're writing scripts. Each of the following examples demonstrates the command substitution. The first one here, we're going to substitute the variable date with the actual command date. Okay, so when we echo date is variable date, we're going to actually get the output the date is and whatever the date is. Okay, same with users. So in here we're going to put the user's variable equal to the variable, so you see $sign here to designate it's a variable. Command who, pipe, and then the word count of who. Okay, and then finally we have echo logged in users are and the variable of users. Okay, and it's going to give you the output of this. And the last example we have here, the variable up equals, and then we're going to use the date command and uptime command. We're going to put both the outputs of that into the variable up. And we're going to echo uptime is variable up, and it's going to give us the output of that. So let me go ahead and open my VirtualBox here and kind of give you examples of that and show you how that actually works. So first in here we're going to say set the variable date equal to, we're going to do double quotation mark, $sign because it's a variable, and then parentheses, open parentheses, date, and then close parentheses and double quotation mark. So now we set the variable date equal to the command date. Now when we do echo date is, and then we're calling a variable, so date, close parentheses. Oops, spelled that wrong. Oops, spelled it wrong again. Alright. We're going to get the command there. Date is Thursday, 13th of August, 2020. It gives me the time and time zone there. Okay. Let's do that for users as well. Users equals double quotation marks, $, open parentheses, who, space, pipe, space, word count, -L, close parentheses, and close quotation mark. And we're going to call that variable. We're going to say echo, parentheses, logged in users are, we're going to call the variable users, and we're going to close parentheses. So say logged in users are 1. There's only one user logged in. Finally, we're going to make the variable up equal to quotation mark, $, parentheses, date command, semicolon, because we're running two commands here, uptime, which is also another command, close parentheses, close quotation mark. Now we're going to echo uptime is, and then the variable up, close parentheses. Uptime is the date, and then the command uptime. So let me go ahead and show you separately what those do. So date command gives you the date, and uptime gives you how long this server's been up. Okay. So when we run the uptime command, it shows you how many users have been on it, the load average, how long it's actually been up, and when it was brought up. Okay. So you'll see here these two commands were used in concurrent for that one variable. Let's go back to our PowerPoint. So next we're going to look at quoting and escaping meta characters. There are three options to avoid shell interpretation of meta characters. So we can escape meta characters with a backslash. We can use single quotes around a string, or we can use double quotes around a string. Now take note, single and double quotes protect each other. So if we look at the examples below, we do echo, hi, intro to UNIX class. So we have single quotes on the outside here, and we have double on the inside here. So when we do that echo, it's going to say hi, and it's going to keep the double quotation marks there. Hi, intro to UNIX class. Okay, so these single quotes say, hey, take this literally, echo exactly what I have inside of here. Okay. Reversely, we have the same thing with double quotes. Echo, double quotes, hi, single quotes, intro to UNIX class, single quote, class, and then double quotes. It's going to say hi, and you'll notice the single quotes here, intro to UNIX class. So these are just protecting and saying, hey, whatever's inside of here, interpret it literally, okay? And then the backslash character will do the same thing for special characters. So we say echo, double quotation mark, backslash, meaning, hey, ignore this next one here, interpret it just as it is, 9,800 double quotes, okay? So if we weren't to put that there, it would actually look at this as a variable. It'd say, okay, well, I'm going to go look for the variable 9,800. We're using this backslash here, and now it's just saying, hey, ignore that, interpret it as is. So it would echo out $9,800. Okay, let's go ahead and talk about some different shells that are available. Don't worry too much about these or how to get them or what they do, guys. Just be aware that there are additional shells available outside of the normal shells that we use. So by default, most people are going to use the bash shell, B-A-S-H, which stands for Born Again Shell. This is the default shell. However, we do have other shells, such as the Z shell. So the Z shell is a Unix shell that can be used as an interactive login shell and as a command interpreter for shell scripting. Z shell is an extended Bourne shell with many improvements, including some features of bash, corn shell or K shell, and TC shell. So let's head to our VirtualBox here. Let me show you how to get Z shell. So if we want to install Z shell, what we're going to have to do is we're going to have to do a sudo apt-get. So sudo apt-get. Then we'll have to do install Z shell. Install ZSH. So you can see it's loading. And there we go, it's installed. Okay. Now if I'd like to switch to that, I'd have to do change shell, CHSH-S for shell, $ for variable, open parentheses, which, and then Z shell. Okay? And I'm not going to hit enter because I don't actually want to switch shells, but that's how you would switch shells. Okay? And just be aware that there's other shells out there that are available to use. The other shell we can look at is going to be fish shell. So the fish shell, that's a tough one to say in a row. Fish shell is a smart and user-friendly command line shell for Linux, Mac OS, and the rest of the family. Fish is a more modern shell with the goal of being more interactive and more user-friendly than older shells. Unlike its competitor, Fish shell is based on the Bourne shell, is not based on the Bourne shell or the C shell, but attempts to blaze its own path. So Fish shell comes with some nice features such as auto-suggestion as you type, syntax highlighting with extensive error checking, searchable command history, 256 terminal colors, advanced tab completion, web-based configuration. A special help command gives access to all Fish documentation in the user's web browser. Error messages designed to actually tell the user what went wrong and what can be done about it. So normally you'll see in Linux it just says command not found or gives you very vague or general errors. Fish shell will actually give you a little bit more in-depth details about what happened. Universal variables, support for the X clipboard. And you can change Fish settings by editing the home/.config/fish/config.fish file. There's also man page completions. It's fully scriptable with syntax that is simple, clean, and consistent. And it has features work out of the box without any configuration. Okay, so there's a lot you can do with Fish shell features. I'm not going to go over it here, guys, just because, like I said, typically you're going to be working with Bash shell. That's going to be the default shell for most people. And if we incorporate Fish shell here, I think it's just going to add a little bit too much for you guys to realize. So let's go ahead and focus just on the Bash shell for now. Let's go ahead and move on to command execution here. So the exec command in Linux is used to execute a command from the bash itself. So this command does not create a new process, it just replaces the bash with the command to be executed. If the exec command is successful, it does not return to the calling process. So we can see an example below. We have bash, okay, and we're going to do exec ls, and it's going to give us ls command, and then it returns itself back to the bash shell. Okay. We also have startup files. Linux is a multi-user program, as we discussed before. It's a time-sharing system, and this implies that more than one user can log in and use the system. System administrators have the task of managing various aspects of how different users can operate a system in terms of installing, updating, removing software, programs they can run, and files they can view and edit, and so on. Okay? So really, a system administrator can actually alter the sudo rights. So you've seen me type in sudo on users. So you can actually alter and configure what commands users can run and what privileges they actually have using sudo commands. Okay. So when a user starts up their system, these commands are going to, or these files are going to be read, and it's actually going to apply that to their shell. Okay. These are known as startup files. You can also customize a user environment. So we can go into system login script, which is /etc/profile. We can do a personal login script, so we can call a variable home, which is just going to be the home directory, / and then .profile. We also have the shell startup script, which is going to give me the home directory /.bash profile, home directory /.shrc. Okay, so we can alter the user environments in those files. And here's a couple examples of different variables we can alter in the environments. We have JDK, JVM, as well as the path variables. We can set the user's terminal type. We can also customize the user's prompt. And we can set a default text editor for them. We can set up history file size and location. We can run reports as soon as you log into an account, and more. We can also set a command line shortcut and aliases. Okay, so these are all pretty advanced concepts, guys. We're just scratching the surface here. So we're going to go into more detail in intermediate and advanced Linux administration courses about the user environment, customizing variables in here. Just understand that as an administrator, you can actually alter a user's environment and limit them on what they can and can't do, as well as determine the defaults of their environment and how it looks and how they can interact with the shell. So in summary, we went over shell functions today, input and output redirection in pipes, command separation and grouping, background execution, file name expansion, shell variables, command substitution, quoting and escaping meta characters, Z shell features, fish shell features, command execution, startup files, and then customizing the user environment. In our next section, we're going to go over multitasking, schedule, execution, and using cron jobs, and the at and batch commands. Guys, please don't hesitate to follow these links here. If you're having issues or troubles with the things that you're learning, we have private tutoring sessions for system administrator, weekly and monthly plans, and we also have private tutoring sessions for Linux and Bash scripting. Thanks so much for joining me, guys. I look forward to seeing you in session 6 and 7